In this example, we're going to learn how to simplify a rational algebraic expression. By rational, we mean it's a fraction. It comes from the word ratio, which is a comparison of two numbers, usually written as a fraction. It is algebraic because it has variables, and it is an expression, not an equation, because it doesn't have an equal sign. One of the most common mistakes that students make is that they start reducing from this point on. However, you can't start hacking away and reducing this fraction because you have plus and minus signs in the numerator. As long as you have plus or minus signs in either the numerator or the denominator, you cannot reduce the fraction at this point. However, we can split it into three parts. We take the first expression in the numerator and write it over the same denominator. Then we go to the second expression and write it over the same denominator, remembering to bring your minus sign with you. And then the last part, the plus 12x squared y, over the same denominator. These expressions have the same value as our original problem, but they are now split into three expressions. And we can reduce each one of them independently because each one does not have plus or minus signs in the numerator or the denominator. Before we proceed, let's review a rule of exponents dealing with division. For example, if we had x to the fifth over x squared, this means x as a factor 5 times over x as a factor twice. And now we can reduce this expression by simply crossing out two of the x's in the numerator and the denominator, leaving us x to the third power. We can reduce this work down to a simple rule. Why don't we just subtract the exponents? X to the 5 minus 2 is equal to x to the third. Since there were more factors of x in the numerator, of course the x that's left over, the x cubed, will be in the numerator. This is a mistake also that students often make, putting the x cubed in the denominator when it belongs in the numerator, or vice versa, so we'll have to be careful. We return to our problem, and we will simplify the first expression we see. 4 into 16 is 4. We saw that x to the fifth over x squared is x cubed, and similarly, y to the 5 over y to the 3 is y squared in the numerator, because the 5 is bigger than the 2 and the 3, so there were more factors of x and y in the numerator than there were in the denominator. We go to our second term. 4 into 8 is 2. X to the 4 over x to the 2 reduces down to x squared in the numerator, where there were more factors of x. And y cubed divided by y cubed is the same as any number divided by itself, which is simply 1, and we don't write a factor of 1. We go to the third part. 4 into 12 is 3. Then x squared over x squared, again, is a number divided by itself, a factor of 1. Then y over y cubed reduces to y squared in the denominator, because when we subtract the exponents, 3 minus 1, we get 2, and there were more factors of y in the denominator than in the numerator, so the y squared is in the denominator. Be sure to study this problem carefully and understand why every step was carried out as it was.